Speak Student!
Proving lines are parallel, a la Shmoop. On the forest floor, tensions are brewing. It seems two snails are in the midst of a heated argument. They are worried that their paths on the forest floor may cross. If that happens, they might crash, and they just let their insurance lapse. You know what snail insurance costs. But hang on a sec, do they really have to be worried in the first place? Let's discuss. By definition, parallel lines never cross even if they go on forever. If we can prove that these snails' paths are parallel to each other, then they can stop arguing and leave the forest undergrowth in peace. We've got several important theorems and postulates to help us out. All of those theorems and postulates have to do with transversals, a third line cutting across the two lines in question. That's a transversal. A straight branch lies across the snail's paths that can serve as our model of a transversal. A transversal will create 8 different angles we should examine before reaching our conclusion. The first postulate we can use to determine whether two lines are parallel is the corresponding angle's converse. Remember that corresponding angles refer to angles such as 2 and 6 or 3 and 7, as you see here, which states that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Check, baby. The first theorem we can use is the alternate exterior angles converse. Remember that alternate exterior angles refer to angles such as 2 and 8 or 1 and 7, which states if two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Got 'em? Check. Okay, the second theorem we can use is the consecutive interior angles converse, which states if two lines are cut by a transversal so that consecutive interior angles are supplementary, remember supplementary meaning that they add up to 180 degrees, then the lines are parallel. Consecutive interior angles in this case refer to angles 3 and 6. The branch creates consecutive interior angles measuring 150 degrees and 30 degrees. That's 150 plus 30, which in California is, yes, 180. Magic number. Check. All right, the last theorem we can use is the alternate interior angles converse. So check this out. Alternate interior angles refer to angles 4 and 6 or 3 and 5, which states if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Check-a-rooney, we're good. So it seems those snails don't have to worry about crashing into each other after all, but they just might run into a few more transversals on their journey. Oh dear.